Hello guys, so today we have our experiment solar cell characteristics. For that we will calculate the fill factor over here and understand the characteristics of solar cell obviously. So for that we need the solar cell, which is this one, the multimeter, this one, the ammeter, and the light bulb, and our small potentiometer. And the formula for fill factor is power maximum by theoretical power, and theoretical power equals to voltage, that is open circuit voltage, and short circuit current, which we will calculate and show you guys. Okay, so we have a circuit over here, the circuit diagram. What I'll do is we'll start with the positive side of the voltmeter. We'll finish this ring, and then from the positive part of the voltmeter and from one part of key 1, it goes to the diode. So I'll start from the voltmeter itself. So the positive side of the voltmeter goes to key 2. From key 2, the other part of key 2 goes to the positive side of the ammeter. The negative part of the ammeter goes to the potentiometer over here. The other part of the potentiometer goes to key 1, and we complete this circuit just that key 1, one part of key 1 again goes back to the voltmeter. And all that remains is connecting positive part of the voltmeter with the positive side of the diode and one part of key 1 with the negative side of the diode. So as you can see, the negative side of the diode goes to key 1 over here, and the positive side of the photocell or the diode goes to key 1, which is again connected to the voltmeter. Okay, so if we read the procedure over here, the first thing says that connect the solar cell according to the diagram, which we have already done. And now what we have to do is we have to place this solar cell so that the light from this bulb falls normally, is incident normally on this photocell over here, and this much distance is enough to get like good values. It's fine. So we place it like this. It's done. Now what we do is we take this potentiometer. We take this potentiometer and we keep it at the minimum value. So minimum value is you rotate it counterclockwise until you cannot move it anymore. Counterclockwise again. So you have it here, the potentiometer. And now you calculate two things. One is short circuit current and the open circuit voltage. So for short circuit current, what you do is you remove key 1. Let's remove it here. I'll turn on this bulb and you take 150. You try to keep it at 150. This is the short circuit current. So you take that reading over here. Then you what you do is you close the switch, that is key 1. And now you take out this one from key 2. And you take this reading. You get somewhere around, like you take whatever the reading you get, it comes somewhere around 0.47. Now you're getting 0.49. So it's fine. Okay, so to start the experiment properly, after noting down the short circuit current and open circuit voltage, what we do is we place this key 2, close this. So both the keys are closed right now. So and while closing this, make sure that you place it down, because most of the time you don't get reading due to loose connection. Both of them show 0. Start your experiment by changing the potentiometer. That is, right now it's at the minimum value, that is maximum counterclockwise position. You rotate it so that this reading changes in steps of 0.01. So you change it. It's very sensitive. So I had 0.190, so I'll try to get it 0.2, like this. It changes, so try to like change it in steps of 0.01, and you take the corresponding reading. Okay, so the range that you get, you have noted down the voltage to be somewhere around 0.47 or 0.49, right? So while you change the voltage in steps of 0.01 and note down the ammeter reading, you will do this till you get the maximum voltage. That is, you started with 0.15, you changed in steps of 0.1 all the way down till the maximum. For me it was 0.47, you had 0.49. right now it's showing 7 again, 6 again, so it obviously changed, and you note down the current rate. Now what you do is you calculate the power, that is power equals to voltage times current. So you take the corresponding voltage and current, you multiply, and you put simple multiplication. After taking the readings, what you do is you plot this graph of current and voltage. You mark ISC and VOC. It's just simple plotting. It comes down like this. And this IM and VM is the maximum current and maximum voltage that corresponds to the knee point. So if I come back here, the maximum power over here is at 29.049. So the corresponding maximum current and maximum voltage would be, current would be 126.2 and this one would be 0.23. So if I come back over here, as you can see, it's 126.2, and obviously while plotting the graph you take suitable scales for both the axes. So current you have 126.2 and voltage you have 0.23. So now you calculate fill factor using the Vm and Im over here that you got from this plot. So Vm times Im by VOC by ISC. VOC and ISC you had already noted down. So just the ratio, you get somewhere around this 0.392. That is just a number because the dimensions cancel out. It's dimensionless. And then you show the calculation, and this one was something extra that I had to do. It's not needed for the exam. So we had to calculate efficiency for some reason. And then you write down the result, as in open circuit voltage is this, short circuit current is this, and the fill factor of the solar cell that you calculated is whatever you get.